All right. So welcome to our presentation. Many thanks that you're joining us here. We have three of us doing the presentation, and we have only 15 minutes. So we need to hurry up. We have way too much slides. So some slides we will just skip. Some we will really briefly tell you what is really on it. Because we are three people and three lads really trying to share what we're trying to do here. So yes, you can see here, the topic is the most sustainable modular OCP data center in Denmark. This is what we're trying to share with you, and we are revealing this for the first time here. So you should be a bit honored because we're sharing this for the first time with you guys here. So you have a bit of an advantage towards others. The clicker doesn't seem to work, so I do not need to do it manually here. Again, we are three lads here. It's David, Henrik, and myself. You can see, so David and myself, we are independent consultant, but also we are working for OCP, and Henrik is working for Huawei. Yeah. So in terms of order, so basically I kicking off, as you can see. Then David is coming in. I will come back with some use cases. And then David is coming back, and then the final done is done by Henrik, and this will be about the actual project, the data center we are trying to really to implement in the end of the day at the end of this year in the beautiful country of Denmark. All right, so let me click you through here. This is something you've already seen yesterday when George has done his keynote. These are the well-known 5 tenets of the OCP foundation. I mean, you can read it yourself, but efficiency, scalability, impact, openness, and last but not least, sustainability. So sustainability, as you know, is really on our agenda since more than 2 or 3 years. And this is actually also the buzzword in many of data center fairs and events we are also visiting and attending. How to really create data centers nowadays as sustainable as possible. And this we are trying really with this project here. And I would like to take the next slide. Time is running, as you can see. This is a slide you're probably familiar with, and I need to admit, I nicked it from a good friend of mine, and you know this guy. His name is John Laban. He's not here, unfortunately, but John Laban, as you know, he's the OCP evangelist, and he's created that slide. But I liked it that much, and I have also his agreement, or his, he was okay that I'm using it. As you can see here, these are the different steps when it comes to really how really to cool a rack in a data center site. So let's say if it's per rack is 30 kilowatt, then it's still air-cooled, and it's still okay. If you're going between 30 and 60, then of course you need to think something else, and then it's something which you're using as a water cool. So have let's say it's the simplest one is a rear door cooling you are having there. And if it goes above 60 kilowatt, then of course you need to think something else. It's like immersion cooling, direct chip cooling, you name it. So these, I think, is really a nice slide, and yeah, I've taken the liberty and take it from my friend John. Okay, so. Next slide is already, I just click it through. David, all yours.
Yes. Just to relate the impact of data center industry on the carbon footprint. So energy which is consumed by data center industry, it's roughly 1% in 2008. And if we take into account the PUE, average PUE 1.6, there is a lot of action to improve that, and this is just numbers which you can have in your mind. And next thing is how it works. So right now we have linear carbonized economy. It means that we burn fossil fuel to produce energy and the heating, and at the same time in the energy grid we have renewable power which goes mainly for the data center. And that center converts all that energy to the heat, which is rejected to the environment. And this is direct heating. And also there is a water consumption, etc. But this energy, which goes to the data center industry, is equal to 145 million metric tons of CO2 emissions. And this energy which is released to the atmosphere is enough to melt down the iceberg, which surface is 400 square kilometer, and in nature it requested 10 years to melt down that iceberg, but we done that in just 1 year. And what is combined heat compute? So there is 3 options to make heat transfer from the IT equipment to the heating. So there is air, there is on-chip, and there is immersion. But in all 3 cases, we can make heat reuse. When we have air-cooled data center, we have low-grade heat. We have low temperatures of the water. It is 20-30 degrees. And in order to have useful heat, we use heat pumps. But we still can make heat reuse. And in case of on-chip cooling, 80% is rejected by the CPU in well-performed servers. And 20% is still air-cooled. But 80% is ready to use for heating, and 20% as I show in previous case. And third one is immersion cooling, where we reduce energy consumption of the servers, but all the heat which is rejected by the servers are usable for the heating. And now, Stefan.
Thank you, David. So as promised, I'm back. So I have 3 use cases I would like to share with you. I could possibly talk ages about this one. I love this one because it's Eco Data Center from Sweden, but really briefly, as soon as possible, they at the forefront when it comes to how to run a data center as sustainable as possible. So they have done their homework, and they have been recognized by third party as being, at this point of time, the most sustainable data center provider worldwide. Just briefly, as you can see here, this is the site, the main site in Falun in Sweden. They're building a 6th site now. They have more than 1 site in Sweden. They only build data centers in Sweden. And what they do, they build their sites completely out of wood. The CO2 is embedded. Yeah, it's a renewable material. It's from really around the corner, 50 kilometers where this site is located. They're getting the wood from. It's done locally with local craftsmen. Everything is done really locally, and the CO2 emissions are excellent. So you can see on this graph, it's actually a negative CO2 emission. This is based on the fact that they're making use of 100% renewable. They're using the waste heat, or the heat rejection is transferred to a factory close by. You can see it on the picture in the background. It's a factory producing wooden pellets, so they're drying the wooden pellets, and at the same time they also fed it into the grid of the local utility company, which is Vattenfall in this case. So, but I need to hurry up. Time is running. Another use case, Green Mountain. They're also really innovative when it comes to how to run a data center sustainable as possible. So they're using the excess heat to really transfer to a lobster farm there close by. And here, also a favorite of mine. I don't know if Jeroen from Blockheating is in the audience. Obviously not, but here, this is an example from the Netherlands. They producing also modular data center sites. They place them really local to some greenhouses. They have some greenhouses, as you can imagine, in the Netherlands, where they really grow vegetables, and they're using the excess heat here to grow those vegetables. Yeah. All right, and last but not least, and this is also the bridging or the crossover to the actual project which Henrik will share with us. This is the current Facebook data center site in Denmark, in Odense. And as you can see in the middle, there is the local district heating company, and the name is Frenzel. And they're the biggest provider in Denmark, and they're doing a great job. And we are doing our project, by the way, with this company called Frenzel. And so what they do, they're using the rejection heat, transfer it over to to the grid. And in the winter, the heating is done of 12,000 houses of the city of Odense. At the same time, in the summer, excuse me, they also do the warm water of these houses. Yeah, so this is also like a circle. I don't want to go into detail because time is unfortunately running. All right, back to you, David.
So when we choose circular decarbonized approach, we don't burn any more fossil fuel, and opposite, we use renewable energy, convert that to the heat, and provide that to the district heating or production processes. And in that case, we have really sustainable circular approach. So this approach we plan to use in our data center. And now, if that approach will be used globally, and assuming that our consumption will be increased twice, but our energy consumption with that approach will be reduced. And the CO2 emissions which can be saved with that approach is equal to 70% of gas pipeline Nord Stream. So impact is huge. And now, right. Henrik, please.
So this is the actual project. It started by, as Stefan said, it is from the Fjernvarme Fyn. This is a district heating company that asked, can we make heat recovery in another way than we have done previously? And that is what we are proving. That is doable, especially with the OCP cooling parts. So the discussion started with a modular and scalable system. Now I'm from Denmark, so it's like a Lego system. You just have some modules you build and you put them together. So from a sustainability point of view, it is quite good because you are saving so many of the Scope 3 costs by doing this in this way. Another part is, of course, we are looking into the cooling system from OCP because we are working with very high temperature settings. So it was the wrong way. This way. So looking at the holistic data center installations we are going to make is to see how can we have dual infeeds for the energy. That means the grid. And how can we make grid resilience also to, for instance, embed energy storage systems and also have mid-voltage UPS systems connected to it. But also most important is how can we connect that to the OCP cooling methodologies. So we look first of all to what kind of cooling solutions are we looking into. We have, for instance, the air-cooled racks, and we have a water-cooled racks with chip cooling. And this is actually where we are, because this is high-performance computing, so we need high density in the racks. So from that part, David have made a cooling solution to run it for how can we run this chipset at very, very high temperatures. So what we actually try here is to run it at 70 degrees to the grid and also have a return temperature for 40 degrees. But this means that we don't need a heat pump for the major installations or the major heat load. We only need a heat pump for the rest of the cooling we need that we cannot do with the chip cooling. So this is a very high density, but also from the heat recovery point of view, very good solution. So when we look at it from the district heating point of view, this is there different ways they are making district heating over a year. So for instance, the brown level you have here is where they are paid for the government to burn waste. We cannot compete about that because this they get paid to actually make district heating. And one of the things they make from burning this is, of course, electricity and district heating. The next part, the yellow line, is where they are burning hay from the farmland. And then when you look up at it, you have wood chips, you have, for instance, electrical boilers, and we end up in the black up there. That is actually where they have to burn gas to make the district heating. So when we look at the cost, what we can compete here is actually they are willing to pay us for the comparison between making this for burning hay. That is the yellow line. And that is because they know in the future how to burn waste because of the sorting we have will be less and less waste in the environment, so that they cannot burn it anymore. So that is what, and this means we are actually going to be paid per megawatt hour for delivering the heat for these district heating systems. And as long as we compete at the level of the brown, we actually can get paid all year round because they have a yearly consumption for nearly 100 megawatts all year round. So this means we can get paid for delivering the heat for all year round for this. Another point we have here, I will make this short, is actually we also using the energy storage systems to convert, so we are not using PPAs, we actually use the electrical spot prices. Because if you look at the prices here, we go from what is 8 cents per megawatt hour to, I think it's 850 euro per megawatt hour. That is more than a factor of 1,000 to do that. So by adding energy storage systems, you can actually go to have a better resilience, but also you don't need to pay the high cost for this time for it. That means that you also, when you know that the price is very low, it's also because you have a lot of renewable energy in the grid at these times. So this is the next bonus we get from it. But I don't know, do you know about the Nordic Initiative Challenge? We are actually paid by delivering ancillary service into the grid. For instance, I think you know about the FFR, that is fast frequency reserves, where we are helping the grid when the frequency gets low, we help the grid to stabilize again because of all the renewable energies in the grids. There is a lot of other options when you have energy storage also to help the grid to be stable and resilient for that point. This is payment you get when you are delivering these services. So it's not only green, it's actually also a business by itself. So in short terms, we are trying with this project to look into the green energy. How can we make the purchase and the usage of the energy in a better way? Next part is to how can we predict the energy consumption for the energy for the usage of the data center. The last part is, of course, we have implemented battery energy storage systems to make the differentiation between how we purchase and how we use the energies for these parts. This was just in very short terms about the project.
All right. Thank you, Hendrik. All right, so this is the last slide, and apologies that we really rushed through this presentation. We're already over time, so again, also apologies about that. At this stage, we are not really in a position to show you all the details because, as you can see here from that last slide, the next stop for us is to go to China and to officially sign, all parties involved, all stakeholders involved, to sign the letter of intent. And then, of course, we are more than happy to share even more details. This was really a brief overview for you guys. Of course, also happy if you have afterwards time to ask us some questions. Again, I think we're already more than 2 minutes over the allocated time. We appreciate your attention. Again, we will be here. As you can see, we will also be at the Global Summit in San Jose in California. At that time also, we will be in a position to really show you more details. Hopefully, it was already to see what we are planning to achieve there, really making use of the excess heat there. Many thanks for your attention. Any questions straight away from your side? Not really? So, thanks very much. You take care, safe travels. Thank you, guys. Thank you.